Viewer discretion is advised.
Alright, let's do it for you this time. I'm going to use Google Colab and we're going to import the library we need. Okay, so the next step would be creating a model, right? Like, no, are you kidding me? We have to define the task, get the data, collect data, and analyze it. For interaction example, I guess people usually do classify dog or cat, but here we're gonna do bear versus snail. We're gonna do data collection right now. Let's look for some bears on Google Images. Okay, let's say some image from here, and I'm going to use them as training examples. So now we're going to look for some snails. Look at them, aren't they beautiful? Delicious too. Actually, I don't know if bear meat is good or not. I think I have eaten snail before. Maybe I have eaten bear meat. I was fed like a lot of weird shit when I was a kid. Alright, now I have 10 images of bears and 9 images of snails. Next step, we need to upload those images to this machine because it's still on my desktop right now. So I'm gonna try to create some folders. Now all our training images have been uploaded to the cloud and ready to be read. We're gonna need to swap the blue and red channel beside the image too, because machine learning model usually expect a fixed size. And I'm gonna make this into a function. We can try to read all the images into the memory by walking through the out directory. 11 bears images and 10. I miscounted or something. Oh, I counted starting from 0.
Autobots, roll out. We roll.
Here we're going to use a pre-built image model from Torch Vision. I want to use something simple. I'm going to use ResNet 18. Now let's say you want to run this model on a single image. What you want to do is you call the forward function on that images. It didn't work. Machine learning model usually process batch of data. So this model is expecting a batch of images, and it had to be in the tensor format. If you look at the shape here, we have I have 1 images. The size of the image is 200 something, and 3 channel red, green, blue. But the format that they are expecting is that the depth channel here has to be the second dimension. So we need to change that. So when you read the images in with OpenCV, it is integer value between 0 and 255. So we need to convert them into floating point between 0 and 1. It works now. So this looks like the result is 1 by 1000 matrix, where we have 1 image, and 1000 is the number of ImageNet categories, because our model is a pre-trained one on ImageNet dataset. Let's look at the model itself. It has a bunch of conformal layers, residual block. So the last layer is the classification layer from the image feature to the number of classes. So we have 1000 classes. Now we want a bear versus snail model, so we need like 2 classes for our model. Okay, we have a bear versus snail model. For example, here the output will be the score of each class. Let's say the first class is bear and the second class is snail. Let's run this on all our images. Results look garbage because we haven't trained our model. I'm going to create a training dataset by combining the bear images with label 0 and the snail images with label 1, as this is our training dataset. And you want to need an optimizer to train our model. So cast the gradient descent optimizer. Now training will happen in a so-called loop. each iteration, we will run the model on the trained images, compare with the trained labels, and update its parameters. Pay close attention because this is the meat of the video. This is where the magic happens. So this is how each iteration is done. First, we need to reset the optimizer. Then we set the image model to train mode and run it on the training data. To evaluate how good the result is, we're going to define a loss function that compare the result with the trained labels. Because we're doing classification, the standard loss for this task is cross entropy. The loss looks the same because we haven't been done any update to the network yet. For that to happen, we need to call loss backward for it to perform gradient backpropagation, and then we're gonna call optimizer step. Okay, it's working. The loss is going down. And by the way, the loss represent the performance of the network. You could see the loss value going down, so your network is getting better and better. If the loss are stuck at similar range or similar value, then something wrong with your training. Now here's the loss. The value can be very slow. Gonna increase the learning rate. Okay, that's better. Loss value is small now, so our network should be really good. We're gonna go back to the previous step and run our network on the image again and see what the result look like this time. It did well on all 11 bare images, using the score of the first class is bigger than the score of second class. Now let's change it to snail. Great, it looks good. Ooh, is that a bear? Screw this. So last step, we're gonna deploy our model. Actually, we're gonna run the model on some new images. Let's find some new bear image. New bear, and then see if our model will work. Alright, looks like it works. It's a bear. We classify this as snail. It looks like a polar bear. They couldn't recognize the polar bear. God damn, this model is racist.